Question number 1. Solve the following simultaneous equations using the eliminations, substitutions, or graphical representations methods. So for the questions A here, I'm going to choose the substitutions method as it is easier in this case. So first I'm going to label the equations as 1 and 2. And I'm going to choose the y from the equations 1 to become the subject of the formula. Therefore, I'm going to move this y to the right hand side and this 7 to the left hand side. So y is equal to 2x minus 7. I'm going to label this as my equations number 3. So next, I'm going to substitute the equations 3 into the equations 2. So you're going to get 2x minus 7 squared and replace the y with 2x minus 7. So for this part, we're going to expand it. So 2x, when you square it, you're going to have 4x squared. And when this 2x multiply this negative 7, you're going to have negative 14. Double it, you're going to have negative 28x plus 49. And I'm going to solve this first. So next, I'm going to expand for this part. So for this 11, I'm just going to move it to the left hand side so that I can write these quadratic equations in general form later on. So next, we're going to solve for the like term. So 4x squared minus 3x squared, you want to have x squared. And negative 28x plus this 7x, you're going to have negative 21x. And this positive 49 minus the 11, you're going to get a positive 38. So this is the quadratic equations that has been written in the general form. So we're going to solve this. You can use the factorization method or the formula. So as these quadratic equations, the answer is in a whole number. So you can solve this using the factorization method. So if you use the factorization method, you're going to have x minus 19 for the first bracket. And the second one is x minus 2 equal to 0. So for this part, you actually can use the calculator to help you. Alright, so therefore the x is equal to 19 or the x is equal to 2. So now we're going to find the value of y. So we need to substitute the x equal to 19 and the x equal to 2 into equations number 3. As in equations number 3, the y has been the subject of the formula. So y is equal to 2 times 19 minus 7 for the first one, or the other one will be y equal to 2 times 2 minus 7. So here you're going to have 38 minus 7, which is 31. Here we're going to have 4 minus 7, which is equal to negative 3. So the answer for these questions, the A, is when the x is equal to 19, the y will be equal to 31. And the other pairing will be when the x is equal to 2, the y is equal to negative 3. Questions B. So let us label the equation first. So for these questions, I'm going to show you how to solve this using elimination and substitutions. As if you look at here, we already have the value of x in equations 1 and 2, which is equal. So it is convenient in this case for us to solve this using the eliminations method. So we're going to eliminate the x. So we're going to use equations 2 minus equations 1. So when x minus this positive x is equal to 0, so 3y squared minus nothing, so you're still going to get 3y squared. And then we're going to minus with this 5y. So it's going to be negative 5y here. And negative 1 minus the 1, you're going to have negative 2. And next move this negative 2 to the left hand side. You're going to have 3y squared minus 5y plus 2 equal to 0. So therefore, you already have the quadratic equations in general form by just minus the equations 2 to equations 1. Or you can also solve this by using the substitutions method if you like to. So I just going to choose the x from the equations 1 to become the subject of the formula if you want to use the substitutions method. So from equations 1, the x is equal to 1 minus 5y. So I just going to label this as equation 3. So later on, I'm just going to sub the equations 3 into 2. So 1 minus 5y plus 3y squared equal to negative 1. So then move the negative 1 to the left hand side. You're going to, and arrange this. You're going to get 3y squared minus 5y. So here you're going to have plus 1 and plus another 1 from the right hand side. So therefore you get 3y squared minus 5y plus 2 equal to 0. Alright. So I'm just going to write the equations here. So for these questions, you are actually able to factorize it completely. Therefore, I'm just going to use the factorizations method. So the first bracket, you're going to have 3y minus 2. Another one is y minus 1. So y is equal to 2 over 3, or y is equal to 1. Alright, so now we're going to find the value of the x. So I'm going to substitute the y equal to 2 over 3 and the y equal to 1 that we find. Here I'm going to substitute it into the equations 3 from the substitutions method, because the x has been the subject of the formula. So you're going to have x equal to 1 minus 5, 2 over 3 for the first one. Then this is the second one. So here you're going to have 1 minus 10 over 3, which is equal to negative 7 over 3. Here you're going to have x is equal to negative 4. So the answer for questions B will be the first one, when the x is equal to negative 7 over 3, the y is equal to 2 over 3. And another pair answer is when the x is equal to negative 4, the y will be equal to 1. Question C. So first let us label the equations as 1 and 2. So I'm going to choose the substitution methods for question C, as this is convenient because in equations 1 we already have the y as the subject of the formula. So I'm just going to substitute the equations 1 into the equations number 2. So you're going to have 1 over x minus 1 over 3 minus x equal to 2. Now I'm going to equalize the denominator so that I can write combine the fractions together. So the x here, I'm going to multiply it by 3 minus x. And for the other part here, I'm just going to multiply it by x. So now you're going to have 3 minus x over, now I can combine these two fractions as they already have the same denominator. So this Denominator will be 3x minus x squared, right, equal to 2. Next, I'm going to solve this one, right? And then I'm going to move this to the other side. So you're going to have 3 minus 2x equal to 2 times 3x minus x squared. So expand this. All right, this is a quadratic equation, so I'm going to move everything to the left hand side so that I can write the equations in general forms. So here you're going to have 2x squared minus 2x minus 6x plus 3 equal to 0. So next we're going to solve for the like terms. So negative 2x minus 6x is negative 8x plus 3 equal to 0. Now, for these quadratic equations, you weren't able to factorize this completely as the answer is in decimal form. So to solve this, we're going to use the formula in this case. So based on the equations, 2x squared minus 8x plus 3 equal to 0, the a will be 2, the b is equal to negative 8, and the c is equal to 3. So you just need to compare it with ax squared plus bx plus c equal to 0. So now we're going to substitute all the value here into the formula, which is x equal to negative b plus minus b squared minus 4ac, the square root, and divide it by 2a. So here the x is going to be negative bracket negative 8, so is alright. So let us solve this. So here you're going to have 8 plus minus square root 40 divided by 4. So you're going to have two answers for the x. One is 8 plus square root 40 divided by 4. Another one will be 8 minus square root 40 divided by 4. So by using your calculator, you're going to get the answer 3.5811 for x. Another one will be 0.4189. So always take your answer until 4 significant figure. So now next we're going to find the value for the y. Alright, so first I'm going to substitute the first value of x, which is 3.5811, into equations 1. So here you're going to find that the y is equal to negative 0.5811. So another value of the y will be, when you substitute the x equal to 0.4189 into equations 1 as well. So the y will be equal to 2.5811. Alright, so the answer for the question C will be when the x is equal to 3.5811, the y will be negative 0.5811. And another pair of answer will be when the x is equal to 0.4189, the y will be 2.5811. Alright, questions D. So first label your equations. So I'm going to use substitutions method to solve for questions D. So I'm going to choose the x from equations 2 and I'm going to let it be the subject of the formula. So x will be equal to 4 over y minus 2y. And I'm going to label this as my equations number 3. So I'm going to substitute this equations 3 into the equations number 1. So I'm going to get 3 bracket 4 over y minus 2y plus 5y equal to 1. So I'm going to expand for this part. Therefore, you're going to get 12 over y minus 6y plus this 5y equal to 1. Now, this negative 6y plus 5y, we can solve it first. So you're going to get 12 over y minus y equal to 1. So next, in order to eliminate the y, which is at the denominator part here, so I'm going to multiply each of the term by y. So by doing so, the y here will be cancelled. So you're going to have next 12 minus y squared equal to y. So next we're going to move everything to the left hand side so that we can write in general form. So negative y squared minus y plus 12 equal to 0. So we're going to let the a to be positive normally in order for us to able to factorize it. So for each of the terms here, I'm going to divide it by negative 1. So that my a will become a positive 1. So here you're going to get y squared plus y minus 12 equal to 0. So I'm going to write the quadratic equations up here. So these questions you are able to solve it by factorizations, as it can be factorized completely. So the first bracket you're going to get is y plus 4, and the bracket is y minus 3. So you're going to get y is equal to negative 4, or the other one, y is equal to positive 3. So next we're going to find the value of the x. So substitute the y equal to negative 4 and the y equal to 3 that we find into equations number 3. So x is equal to 4 divided by negative 4 minus 2 times negative 4. And another one will be divided by 3 and minus 2 times 3. So here we're going to have negative 1 plus 8. So the x is equal to 7. So for the other part, it will be 4 over 3 minus 6. So solve this, you're going to get negative 14 over 3. So the answer for questions D will be, when the x is equal to 7, the y is equal to negative 4. And another pair of answer will be, when the x is equal to negative 14 over 3, the y will be 3. Alright, questions E. So first label your equations. So for questions E, I'm going to continue with the substitutions method. So I'm just going to choose the x from the equations 1 to become the subject of the formula. So from equations 1, so the x is equal to 9 minus 4y divided by 2. So this will be the equations number 3. So next, I'm going to substitute the equations 3 into the equations number 2. So we're going to replace the x with 9 over 4y divided by 2 square. So here another x. Alright, so for this part here, we're going to expand it. So you're going to get, so 9 times 9 is 81. So when 9 multiply this negative 4y, you're going to get negative 36y. Double it, you're going to get negative 72y plus the 16y squared over 4. So don't forget the denominator, also you need to square it. And for this part here, I'm going to simplify it. So here you're going to have 10 times 9, which is 90. So minus 40y. So this part is just like you expanding it. Alright. So next we come to this part. So this one we can also simplify it. So therefore you're going to get, so just get all this thing out of the bracket first. So when 90 minus this 19, you will get 71. And negative 40y plus 4y is negative 36y. Alright, so this is actually a quadratic equation, so we're going to move everything to the left hand side. So, and we're going to solve for the like term as well. So this positive 16y plus this 16y squared, you're going to get 32y squared. Alright, so and then this negative 72, we're going to plus with this 36y when you move it to the left hand side. So you're going to get negative 36y, and then 81 minus 71, you're going to get a positive 10. Alright, so for these quadratic equations, we can continue to simplify it by dividing every terms by number 2. Alright, by doing so, you're going to get 16y squared minus 18y plus 5 equal to 0. So I'm going to write the equations up here. So for these questions, you are able to factorize it completely as well. So you can always check it by using your calculator. So the first bracket is 8y minus 5. The second one will be 2y minus 1. Alright, so here you're going to have y equal to 5 over 8, or y is equal to 1 over 2. Now we're going to substitute these two, the y value here that we find, into equations 3. So you're going to get x equal to 9 minus 4y, and then we're going to divide it by 2. Alright, just solve this using your calculator. Then you're going to get the answer for the first part here is 13 over 4. And another one will be 7 over 2. So the answer for the questions E will be, so for the first pair, when the x is equal to 13 over 4, the y will be 5 over 8. And the other pair will be when x is equal to 7 over 2, the y will be 1 over 2. Questions F. So first label this as equations 1 and 2. I'm going to choose substitutions method as well to solve these questions F, and I'm going to let the x from the equations number 1 to become the subject of the formula. So from equations 1, x is equal to, I'm going to write the positive one first, which is 4. So negative 4 moved to the right hand side is a positive 4, right? So minus y. So this is the equations number 3. So which later on we're going to substitute these equations into the equations number 2. So everything with the x, you just replace it with 4 minus y. So here it will be a square. So for this part, I'm just going to expand it. So 4 square is 16. So when 4 multiply negative y, you will get negative 4y, double it, negative 8y. And then plus y square. And for this part, if you easily get confused, so why don't you combine these two together first? So it will be negative 2y bracket 4 minus y. Alright, so if you notice, here you have a positive y minus positive y square minus y square. So this one will be cancel. Right, it will be equal to 0. Then later on this one, you just need to expand it. So 16 minus 8y minus, so here you're going to get 8y square plus 2y square. Then move these two to the left hand side as well, so that later on we can write this in general form. So we're going to arrange this and solve for the like term. So 2y square, these two you're going to get negative 16y, and then 16 minus 2 is plus 14. Next, I can continue to simplify these equations by dividing every term using number 2. So you're going to get y square minus 8y plus 7 equal to 0. So these equations, you are able to factorize it completely as well. So we're just going to factorize it. So the first bracket, you're going to get y minus 1. The second one will be y minus 7 equal to 0. Therefore, y is equal to 1 or y is equal to 7. So next, we're going to find the value of x. So we're going to substitute the value of y that we already find into equations number 3. So you're going to get x equal to 4 minus 1 for the first one, or x is equal to 4 minus 7. So here you're going to get x equal to 3. Here is x equal to negative 3. So the answer for the questions F will be when the x is equal to 3, the y is equal to 1. And another pair of answer is when x equal to negative 3, the y will equal to 7. Questions number 2. Solve the following simultaneous equations using the graphical representations method. So questions A, draw the graph for the following pairs of equations for the domain x is in between negative 5 and 5. So hence, determine the solutions to the simultaneous equations. So here we want to draw the graph. So the coordinate x has been given here. We want to draw in between negative 5 and 5. So next we need to find the coordinate y, the corresponding coordinate y for each of the equations. So here I just going to label this as equations 1 and equations 2 in order to find the coordinate y for each of the equations easily. So for the equations 1, I'm going to let the y to become the subject of the formula. Therefore, 2y equal to 1 plus x. So y equal to 1 plus x divided by 2. So when you want to find the coordinate y, you just need to substitute the x here with the corresponding value of x. And we're going to do the same for the equations number 2. We are also going to let the y to become the subject of the formula. Therefore, xy equal to 26 minus x squared. Okay, later on y is equal to 26 minus x squared divided by x. So the same thing when you want to find the coordinate x for the equation, coordinate y for the equations number 2, you just need to substitute the x here with the corresponding value, the domains. So here I already prepared a table for us to write down the coordinates. So first, here is going to be the coordinate x, so which is the domain. So we're going to which is in between -5 to 5. And first we want to find the coordinates y for the equations number 1. So first you just need to substitute the -5 into the x, which we already let the y to become the subject of the formula. So just press your calculator to find all the coordinates. So I already prepared here, so it's going to be -2, -1.5, and so on. Right, and the coordinates y for the equations number 2. So you just need to substitute the x here with -5, -4 until 5. So by doing so, this is the coordinates that you're going to find. So if you notice that here I'm going to left is empty, as if you substitute the x here with zeros, is actually undefined. So next, the coordinates that you need to plot on the graph for the equations number 1. So you're going to use the x with this coordinate y for the equations 1, and the coordinates for the equations number 2. So you're going to look at the x with this y. Alright, so this is the graph that I plot using the GeoGebra software. So the solutions for these simultaneous equations is we need to find the intersection point between these two graphs. So we have two intersection points for these two graphs, which one of these is here and the other one will be here. All right, so just find the coordinates for these 2 points. All right, so for the first coordinates here is actually 4.0, and the coordinate y will be 2.5. All right, so here this is our x axis and this is our y axis. And for the second point here, the coordinate here will be -4.3, and as for the coordinate x is -4.3 and the coordinate y will be -1.7. So these two coordinates is actually the solutions for these simultaneous equations. Questions B. Draw the graph for the following pairs of equations for the domain for the x is in between -3 and +4. Hence, determine the solutions to the simultaneous equation. So we also want to find the intersection point between these two graphs. So first I'm going to label these two equations as 1 and 2. So the coordinate x is in between -3 and 4. Next, we need to find the coordinate y for each of the equations. So for equations number 1, I'm going to let the y here to become the subject of the formula in order to find the coordinate y later on. So I'm going to move this y to the right hand side and these two to the left hand side so that I get the positive y. So y is equal to x minus 2. So later on, you just need to substitute the x here with -3 until 4 in order to find the coordinate y. Now let's move to equations number 2. I'm also going to let this y to become the subject of the formula. So 3y squared equal to 36 minus 4x squared. So y squared equal to 36 minus 4x squared divided by 3. And y is actually equal to plus minus the square root of 36 minus 4x squared divided by 3. So in order for you to find the coordinate y, for the equations number 2, you just need to substitute the x here with the value negative 3 until 4. But because you have two possible answer, one is a positive one is a negative one, right? So for the equations number 2, for each of the x coordinates, you're going to have two coordinate y, which is one positive and another one is going to be the negative one. So I already prepared a table here. So for the x, so we just put in negative 3 until 4. So first let us find the coordinate y for the equations number 1. So if you put in the negative 3 until 4 into the x here, you are going to get the value negative 4 followed by negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, and 2. And for the coordinate y, for the equations number 2, you're going to have one which is a positive one, another one is going to be the negative one. So just put in negative 3 into the x for the equations number 2 there. So the first one, you're going to get 0. And for the negative 2, one is positive 2.6, another one is negative 2.6. So here 3.3, negative 3.3, 3.5, negative 3.5, and followed by and if you put in number 4 into the equations number 2 there, what happened is that for this, the value inside the square root here will become negative, right? So for these two value, so we just leave it blank. All right, so there's no need for you to plot it. All right, so this is the graph that I plot using the GeoGebra software. So actually the equations number 2 is a circle and the equations number 1 is the linear one. All right, so now we just need to find the intersection points between these two graphs. So we have two intersection points. So one is here, another one will be here. So for the first one here, the coordinate is going to be, the x coordinate is 2.9, where the y coordinate is 0.9. And for the second intersection point here, the coordinate x is negative 1.2, whereas the coordinate y will be negative 3.2. So the coordinate of the intersection between these two graphs is the solutions for these simultaneous equations.